बोल सकते हो, अभी कोई
आदित्य
दिक्कत नहीं।
वेट कर, सर बोल रहे हैं जब 100 स्टूडेंट्स हो जाएंगे तो ही ज्वाइन करियो।
100 स्टूडेंट्स जब हो जाएंगे तो कहाँ पे ज्वाइन करना है?
आदित्य वेट फॉर एटलीस्ट 100 स्टूडेंट्स टू बिगिन, लिखा है सर ने।
अभी कितने हैं? कॉन्करेंट
चेक करना।
व्यूअर्स 28 है भाई।
29, 30।
और अगर 7 मिनट तक नहीं आते हैं तो? 7 मिनट, अभी 7 मिनट 28 सेकंड का
तब
वो।
थोड़ा इधर उधर की बात की जाएगी ज्वाइन करके, ताकि 2-3 मिनट 5 मिनट और रुका जाएगा, उसके बाद शुरू कर दिया जाएगा ऐसा।
हाँ भाई, अब क्योंकि टाइमर में चला चुका हूँ, 7 मिनट बाद मेरे को तो लाइव जाना ही पड़ेगा।
वही कह रहे हैं, वही कह रहे हैं। हम जैसे ही अपना वो लाइव करेंगे तुरंत आ जाएगा ना मेरा यूट्यूब पे।
क्या चीज? रुको एक
हम
मिनट
जैसे ही अपना स्क्रीन और ऑडियो ऑन करेंगे तुरंत हम यूट्यूब पे चले जाएंगे ना।
यार, यूट्यूब पे तो
प्रेजेंट
तुम
स्क्रीन करेंगे
बीस
जो भी।
20 सेकंड बाद जाओगे।
हाँ मतलब वही वही।
रोहित सर की कॉल आ रही। हेलो। All right, so I'm told that there were some technical difficulties. Yeah, so actually we were facing some technical issues. So that is why the voice was not reaching at your end. But now I think the voice should be clear. So if my voice is clear, can you please tell me in the comment section that, okay, yes, the voice is clear now? So just go to the comment section and type that if the voice is clear now or not. Okay, great. So I can see that my voice is audible now. So basically, what I was saying is that hello and welcome everyone. I was basically introducing myself. So my name is Aditya Jaiswal, and I am an educator at Space India. And why are we here today is for this prestigious event or campaign known as Khagolshala Asteroid Search Campaign, which is basically conducted for all of you to participate in this brilliant campaign and be a part of the scientific community and give the scientific community something at your end. So basically, what we are waiting right now for is to have a few more viewers, because right now I can see that there are 123 viewers, but since a lot of you participated in this campaign, so we will just wait 5 to 6 minutes more, or let's just say 2 minutes more, and then we will begin with our presentation where I will be explaining to you all everything about asteroids, how they function, where they are, what are they made up of, and then we will also be finding an asteroid for ourselves. So I'm sure everyone, each and every one of you, is very much interested and very much excited right now that, oh my god, we will be finding an asteroid. But before we begin, can anyone tell me that what is an asteroid? You can type in the comment section basically that what do you think an asteroid is. Yes, I can see raised hands in the YouTube comment section, but what you can just type in on the comment section that what is an asteroid, basically because we are having this campaign. The name is Khagolshala Asteroid Search Campaign. So can anyone tell me that what is an asteroid basically? So yes, go ahead, type in the comment section. Also, I would like to ask you to like, subscribe our channel, Space India. Why? Because we will keep on bringing such exciting and interesting content time to time, and I'm sure all of you don't want to miss out on these exciting videos and these exciting campaigns. So I would like you, all of you, to like, subscribe on the like and subscribe our YouTube channel as well. Now we are about to begin with our session. Obviously, Khagolshala Asteroid Search Campaign. So I can see all of you have already, a lot of you have already written what is the meaning of asteroid. So basically, yes, I can see the name of Jigmeth. I can see the name of Stanzin, that okay, asteroids are minor planets, okay, a piece of rock moving in space. All right. So yes, almost all of you are correct that yes, asteroid is basically, they are also called minor planets. That is true. They are basically piece of rock in space. Some of you have written they are found between Mars and Jupiter. Yes, that is true as well. Now, before we begin, one last instruction, which is a very major instruction, and all of you should follow it very properly, because this will determine that your queries, like any doubts you have throughout the session, जो भी doubts हैं, anything, any question you come across, like you can't like you want to know that okay, between the Mars and asteroid, the asteroid belt is there, you have any question related to that, or any specific question, जो भी questions हैं, just keep them with yourselves. Basically what you have to do, I will be answering all the questions at the end of the presentation when we are reaching the end. Okay, so all of the questions I will be answering at the end. So what you have to do, you have to, whenever you encounter a question, like let's just say I am explaining to you that, okay, there are many types of asteroid. Okay, so there are many types of asteroid, but you do not understand that what are the types of asteroid. So what you have to do, just go on to the comment section, okay, type your question, and after the question, in brackets, you will type your school name. Okay, follow this pattern very carefully, because if you do not follow this pattern, my team will not be able to take your question and I will not be able to answer it. Okay, so please make sure to follow this pattern. What you have to do, whenever you encounter a doubt or a question, just type that question and in brackets your school name whenever you have a doubt. And don't think that I won't be answering that question. I will be answering that question, but at the end of the presentation. All right, so without any further delay, let's just begin uh, with our presentation. So, as we have already discussed that what we need to know that what are asteroids, right? So, I have already seen that all of you have already said that what all of you have already given me the answer that what are asteroids. So let's just begin with the part that what are asteroids. All right. So what are asteroids basically? You have already given me the answers that asteroids are basically rocks which are present. You have also given me their location. They are present in the asteroid belt between Mars and Jupiter. But before we are about to explain to you that what are asteroids in depth, I would like to congratulate all of you so far for being the selective few. Yes, a selective few in this country. So all of you are the selective few students in this entire country who have this brilliant opportunity to participate in such a prestigious campaign, which is Khagolshala Asteroid Search Campaign, where, as I have already mentioned, you will be helping the scientific community in discovering new asteroids. So, yes, by the time we are done with this session, you will know how you can find asteroids. Okay, so what we have to do now, we would like to start with how we are going to do this. So, how we are going to do this? We will be helping the basically the whole humanity by discovering an asteroid. You must think that how can we help the whole humanity by discovering just an asteroid? Well, by discovering the asteroid, we are saving ourselves basically from any future possibility that an asteroid can impact the Earth, which we will be talking about as we move ahead. So, what are we going to do in this workshop? We will be finding basically, first of all, I will be explaining to you that what are asteroids. Secondly, after I have explained that what are asteroids, we will be moving ahead with the part that where do the asteroids live. Then we will be discussing about the different compositions of asteroids, and then finally when I will be signing off, my fellow colleague Harsh will be taking over, and he will be explaining you all the technical parts. How do you use the software to find new asteroids? All right, so let us begin with what are asteroids. So what are asteroids basically? Asteroids are small solar system bodies in orbit around the sun. So, as you have already said, they are basically rocks which are present up there in space. They orbit around the sun. They are found especially in the inner solar system. So, what do I mean with the inner solar system? So, the first four planets, that is, I'm sure all of you know the names of the first four planets, which are Mercury, Venus, and third planet, yes, where we live, Earth, and then Mars. So these are the inner planets. And since the you have already said that asteroids reside in the asteroid belt, which is after Mars, so that also comes in the inner solar system. All right, so they are smaller than planets but larger than meteoroids. So I'm sure all of you know what meteoroids are. So basically, what meteoroids are, they are a small speck of dust, two small pebbles, which are, when they are up there in space, they are called meteoroids. But when they enter Earth's atmosphere, they are called meteors. I'm sure you have seen those shooting stars, which we call Tutta Tara in Hindi. But it's not a Tutta Tara. Basically, they are a small speck of dust in space, or small rocks. So asteroids, they are smaller than planets, but they are bigger than meteoroids. They are always bigger than meteoroids. Okay, and they are also known as minor planets or planetoids, as one of you already told me that yes, they are called minor planets. So yes, you were correct in your information, and that is great information to have. And so yes, they are called minor planets. Also, I would like to give you an example now. So, when you, let's just say you want to build a house, okay, and you are a builder, okay, you are going to build a house. So, when you are going to build a house, you get all the equipments, okay, you get cement, you get paints, and you get white cement and everything. So, everything you get to make a house. But when you are complete with your house, like when you use all the equipments you have brought to complete the house, when your house is done, तो क्या सारा जितना भी सामान तुम लोग लेके आए हो, लाइक सीमेंट, लाइक पेंट्स, क्या सब कुछ यूज हो जाता है व्हेन द हाउस इज डन? Obviously, no. So when we are done with the house, some of the equipments are still left. Some cement is left, some paint is left. So in the same way, when the solar system was in its formation, so when the solar system was forming, basically the sun formed and then all the planets formed, these some small rocks, they were the leftovers of the solar system. Just in the case of house, some cement and paints get left. In the same way, when the solar system was formed, these small chunks of rocks got left out, and they are called asteroids. Okay, but we didn't know about asteroids from the start. Like we had no idea that there are small rocks, there are big rocks which are flying up there. We had no idea, but we knew about the planet Saturn. So basically, if you would like, even on the net, if you go on the internet and look at a star charts or look at solar system charts back in the year 1800s, what happens that we knew that there were planets till Saturn, okay, but we didn't know that there are asteroids. Why? Because the planets till Saturn are visible through naked eye. Like even in the night sky, we can see through our naked eye that there are planets till Saturn. We can see planets till Saturn, but we cannot see asteroids because, as we have already said, that they are much much smaller than planets. So we didn't know until the year 1801, when Giuseppe Piazzi, basically, he located an object between Mars and Jupiter. So, what he did, after analyzing the sky, he located something between Mars and Jupiter. And can anyone tell me the name of that thing he found between Mars and Jupiter? Okay, that's a very broad category. I will give you a hint. It is the largest asteroid we have ever found. Till date, it is the largest asteroid. So now, can anyone tell me that what is the name of that basically celestial body he found in 1801? And yes, all of you, I'm sure a lot of you know it already. The name of that object was Ceres, and it was named after the Roman and Sicilian gods of grain. But even though Giuseppe Piazzi located it in 1801, we didn't know that it was a planet. We had no idea that it was an asteroid. Basically, we had no idea that it was an asteroid. So Giuseppe Piazzi, he said that it is yet another planet between Mars and Jupiter. So basically, yes, during the earlier stages, Ceres was also considered to be a planet, but afterwards, after doing research, after our technology advanced, we found out that no, actually, it is an asteroid. We gave these celestial bodies a different category and we named them asteroid. Now, asteroids basically, I'm sure all of you have already said that they are basically rocks which are floating up there in space. But is that all? Are every one of them just rocks? Like we have rocks on Earth, so every asteroid up there in space, they are just these soil particles which are merged together and so they form rocks. No, even asteroids are of different categories. Okay, so there are three basically main categories which are asteroids made up of. The C type is the first type, which is chondrite. So these are the most common asteroids which are found there. They consist of clay, silicate rocks, and they have a dark appearance. So these are the rocks you could call, these are the asteroids you could call, which are much more or less like rocks because they are made up of clay and silicate rocks. So yes, these C types, you could say that these asteroids are basically like rocks. They are also some of the oldest objects in the solar system. So basically, when the solar system was made, these rocks were even present back then. So they are the oldest objects in the solar system. The second type being the stony type, they consist of silicate materials, but other than silicate materials, they also have minerals like nickel and iron. And then comes the M type or metallic type, which is the nickel iron based. So basically, the M type, or as the name says, metallic type, they are made up of metals. So we have nickel iron based or metallic or M type asteroids as well. So even asteroids have different categories. All okay, so up there in space, they have, these are the basic three categories. Now we have already discussed about Ceres, right? We have discussed that it is, I already told you that it is the largest asteroid we have found so far. Now, can anyone tell me that what is the actual size of Ceres? It is the largest asteroid. Obviously, it should be huge, right? So, what do you think the size of Ceres is? Maybe it is the size of Mars. Maybe it is size of the Earth, or maybe it is size of Moon. If maybe it is size of the Moon, or maybe it is size of Mercury, which is small. So, what do you think the size of Ceres is? Please type your answers in the comment section. Let's just see that who knows that what is the actual size of Ceres. Okay, so let me break it to you that even though Ceres is the largest asteroid we have found so far, Ceres is still not bigger than our moon. And I'm sure a lot of you must be thinking that no, it should be bigger than the moon or it is equal to the moon, but no. In actuality, Ceres is even smaller than the moon. So basically, here you can see the difference between, basically here you can see the difference between the size, basically the size comparison between Ceres. So I'm sorry, there's some technical difficulty and the presentation has stopped. Just give me a moment and I will share the presentation once again back with you. Okay, so just a second, there's some technical issue here. I'll just resolve that technical issue and I will share the presentation with you. Okay, give me a second. Okay, so these things happen actually when we are through the net and considering these are COVID times, so even the internet works slow at times. So these things do happen at times, but yes, we constantly work to resolve them. And so just give me a moment and I will connect this back again with you. Okay, all right. So let me just share my screen once again so that you can see. the presentation. I'm sure the presentation is visible now. Okay, so yes, we encounter a technical problem, so that's fine. It happens, sometimes it happens. Okay, so where were we? So basically, we were discussing the size of an asteroid. So yes, even though Ceres is the largest known asteroid so far, still Ceres is not bigger than our moon. And here you can see the size comparison. So basically, Earth's diameter is 12,742 kilometers. The moon's diameter is 3,474 kilometers, and now you see that small, the basically the smaller circle at the below the moon, that is the size of Ceres, which is merely 950 kilometers. It is the largest known asteroid, but still it is smaller than, much smaller than our moon. Okay, so moving ahead, that we now know that how big an asteroid can be, because Ceres is the largest known asteroid. But how small can it be? Like, we now know that Ceres is the largest asteroid, but what is the smallest asteroid? So basically, asteroids, they range from the size of Ceres, which is 950 kilometers, to a smaller size, to the size of pebbles. Okay, so they, even the smallest size, they are at the size of pebbles or small, basically small rocks. Okay, so till now we have also found asteroids which have a diameter of 240 kilometers or more. So till now we have found the asteroids which have a size of 240 kilometers or more. Just give me a second because I need, yeah, all right. Okay. So we have found that till now the size of asteroids are 240 kilometers or more. Okay. Now discussing about more about asteroids. So we need to discuss more about asteroids because we need to know that what are these asteroids. We have basically found so many things about asteroids. So now what we said, what we should do is that now we should be we should be discussing more in depth about them. So let me just give you some examples that what are the asteroids. So basically here you can see Gaspra, which is an S-type asteroid. So basically Gaspra is an S-type asteroid, and what were the S-type asteroids? They were stony types. So yes, it is composed of mixtures of rocky and metallic minerals. All right. Then comes dactyl. So dactyl, what is good? What is basically unique about dactyl? So you must be thinking that big, basically the big rock you are seeing, that is the dactyl. No, actually the big rock you are seeing, that is Ida. So Ida is also an asteroid, but dactyl, you should see that on the right side of Ida there is one small tiny white dot. So that is actually dactyl. And dactyl, it is about the size of 1.6 cross 1.2 kilometers. So it is pretty small compared to other asteroids. But what's surprising about dactyl is that for such a small body, it is still round. It is still round, and it is very, basically very hard for a small body to be completely round up there in space for a small body. Okay, so dactyl, which is on the right of Ida, the small white dot, that is basically the uh, dactyl. And also one important factor, that it is also the moon of Ida. So till now we didn't know, basically when dactyl was found, we didn't know that even asteroids have moons. So after dactyl was found, we realized that no, even asteroids have moon. So Ida, basically the moon of Ida is dactyl, and Ida is that big chunk of rock you see, and on the right side the small white dot, that is the dactyl basically. Okay, moving on. Here you can see basically 253 Mathild, which is basically a carbon rich asteroid. What carbon rich? So what basically, it is filled with carbon compounds. That is why you can see it is so dark in color. Basically because it is filled with carbon compounds, so it is so dark in color. Okay, it is basically present in the main asteroid belt, and also Mathilde is like a loose rubble pile. So basically, Mathilde, what it the composition of Mathilde is like a lot of rubbles, a small chunk of rocks. They have been brought together, and let's just say they have been brought to stick together. So that is what Mathilde's composition is like. It is like a loose rubble pile with the density of water. Next comes Eros. Now, what is important about Eros? So, the 433 Eros, it is also yet another S-type asteroid, or basically stony type. But what is important about it is that it was the main target of NASA's near mission. So, what was NASA's near mission? NASA's near mission was Near Earth Asteroid Rendezvous Mission. So basically, NASA sent probes. Basically, NASA sent probes up there. Basically, NASA sent probes up there for the asteroids, and so 433 Eros, it was the target for that NASA's near mission. Now, we have already discussed that where do these asteroids lie, right? You have already told me in this comment section that the asteroids lie between Mars and Jupiter. But is that all? Like all the asteroids, which are all these space rocks which are present up there, all of them just lie between Mars and Jupiter. There's no place else where they lie. That is where we are wrong. That is where basically we are wrong. Yes, the asteroids are present in the main belt asteroids, which are basically between the Mars and Jupiter, but there are other asteroids as well. So here you can see that the asteroids are classified between three basically main parts. So the first one being the main belt asteroids. So the main belt asteroids, what are the main belt asteroids? You have already given me the answer that they are between Mars and Jupiter. So yes, there's this huge belt called the asteroid belt where a lot of asteroids reside in our solar system. But that is not all. There are a lot of NEAs, or near Earth asteroids. So basically, there are a lot of asteroids which are up there in space, which are closer to Earth. So they are near Earth asteroids. So let me just give you an example. So basically, near Earth asteroids, they are between Mars and Earth, you could say. Okay, and in depth we will be going about them as we move ahead. And then comes the Trojans. So what are Trojan asteroids? So basically, these Trojan asteroids, they are those asteroids which share the same orbit with a planet. So I'm sure सबको पता है कि अर्थ का एस्ट्रॉइड क्या है. बेसिकली अर्थ का ऑर्बिट क्या है. सो अर्थ का ऑर्बिट क्या है? सो अर्थ इज गोइंग अराउंड द सन, सो इन अ स्पेसिफिक ऑर्बिट, राइट? सो वी नो दैट अर्थ इज गोइंग अराउंड द सन इन अ स्पेसिफिक ऑर्बिट. So let's just say there is another asteroid which is going around the sun in the same orbit. जो अर्थ का ऑर्बिट है वही सेम उस एस्ट्रॉइड का भी ऑर्बिट है. So that asteroids are called Trojans. So Jupiter basically has a lot of Trojan asteroids. Basically, these Trojan asteroids, they have the same orbit like the Jupiter's orbit. So in the case of Earth, we also have one Trojan asteroid. Basically, there's one Trojan asteroid which was found in NASA, found by NASA in 2011. So we have one Trojan asteroid in our orbit as well. So these are the basic three classifications of where are the asteroids located. So let's just quickly discuss about each one of them. So firstly, the main belt asteroids. So with the main belt asteroids, these are basically present between Mars and Jupiter. They are present in the main belt and they orbit the sun in that belt, and the belt is present between Mars and Jupiter. Secondly, we come to the second category, or the near Earth asteroids. So let me just ask you a quick question. Which asteroids do you think pose a major threat to us? The main belt asteroids or the near Earth asteroids? Which asteroid they pose a major threat to Earth? Like which asteroids you think that these asteroids might get attracted due to the Earth's gravitational force? Like Earth has gravity, right? Earth, anything that is closer to Earth, Earth will start to Earth will start to suck it towards itself because of the gravitational force. So, which asteroids do you think are a major threat to Earth? Obviously, the near Earth asteroids. Why? Because these near Earth asteroids, since they are so close to Earth, they have a possibility that when they are orbiting the sun, they may come close to Earth at some point, and Earth's gravity, because it is huge, it will start to attract those asteroids. And when it will start to attract those asteroids will start to come towards Earth. And if they are small asteroids, they will get burned up in the atmosphere. But if, let's just say, they are big asteroids, they are over the size of 40 to 50 meters, the Earth's atmosphere will not be able to burn it. Basically 140 to 150 meters. So any asteroid which is over the size of 140 meters, Earth's atmosphere will not be able to burn it completely. So that asteroid, it will impact the surface of the Earth. So that is why we are discussing more about NEAs. That is why this campaign is so important. That is why all of you are here for. That is why this Khagolshala Asteroid Search Campaign is such a unique campaign. Because what we do here, we find new asteroids. And when we find new asteroids which are closer to the Earth, now we know that, okay, there's this asteroid up there. And this asteroid, okay, let's just say in 10 to 15 years, it might get closer to Earth. So when now we know that in 15 years this asteroid is coming towards Earth, we can find ways of deflecting this asteroid, or maybe even exploding that asteroid up there in space, so that that asteroid will never impact Earth, and so we will be safe, right? But that does seem like a very boring reason, or let's just say a very sad reason to study asteroids. Like, we need to study about asteroids because if we don't study about asteroids, these asteroids will hit us and we will die. That is a very sad reason, right? But let me tell you a very good and a very cool reason as well why we should study asteroids. So, सबको पता है कि अर्थ पे रिसोर्सेज हैं, राइट? अर्थ हैज गोल्ड, अर्थ हैज स्टील, अर्थ हैज आयरन, बेसिकली अर्थ हैज अ लॉट ऑफ सिल्वर, platinum. We have a lot of resources, right? So basically we know that earth has these many resources, but what we do not know that these resources are also dwindling very fast. What I mean by that is that these resources are getting expended because we as humans, we are using all these resources. So when we are using all these resources, what is happening that the resources here on Earth, they are falling short as the time passes. So these asteroids which are up there in space, they are filled with resources. They are filled with iron, as we have already discussed. They are metallic type. They are filled with iron and nickel. So what we can do, we can find ways of mining. So yes, हम लोग mine कर सकते हैं asteroid को. We can mine asteroids and get these asteroids, basically these metals from the asteroids, back to Earth. Okay, so that is one of the good reasons why we should study more about asteroids. And let me give you a very quick and fun fact. There's this asteroid up there in space known as 16 Psyche. Okay, that asteroid is full of gold. Full of gold. Yes, you heard me right. It is full of gold. And if that asteroid, if we humans are able to bring that asteroid back to Earth, all of us, each and every one of us, me, you, every one of you present here, all of you will be billionaires. Billionaires. That is how rich that asteroid is in gold. Can you believe it? We, all of you, will be billionaires. So yes, we do need to research about asteroids. That is the importance of this campaign. We need to research about asteroids to save us. But yes, there's a good reason as well, because we can mine them. So coming back to near Earth asteroids. So as you can see here, near Earth asteroids are basically asteroids which are present between 1.3 AU from the sun. So what is AU? AU is basically a distance we use a for space. Like here on Earth, we use the distance kilometers, right? So in the same way, in space, we use the distance AU or astronomical unit. So what is 1 AU? 1 AU is the distance from Earth to Sun. That is 1 AU or 150 million kilometers. So because 1 AU or 1 astronomical unit is 150 million kilometers, that is why we have given it a different name as AU. We do not measure distance up there in space in kilometers. We have given it AU. So the distance between Sun and Earth, that is 1 AU. And if an asteroid is present between 0.3 AU, 0.3 AU from Earth, the distance from that of that asteroid from Earth is 0.3 AU, we basically call that asteroid NEAs or near Earth asteroids. So let's move ahead with the fact with near Earth asteroids, and here you can see the edge on view for the near Earth asteroids. Okay, so here you see there are a lot of tiny dots, right? There's orange color dots, these blue color dots, every and at the center there you see a glowing object, that is the sun. And if you look closely, there is a green circle. That green circle at the center, that is basically the orbit of the Earth. So this was the image taken by NASA's NEOWISE mission, and basically this is the edge on view of all the near Earth asteroids. All the small dots you see, they are the near Earth asteroids. So there are so many asteroids closer to Earth. More the reason to research and find more about these asteroids, because there are so many of them. Even in these near Earth asteroids, we have further classified them as into three different subcategories, namely Apollo, Atens, and Amors. So basically, these near Earth asteroids, which are closer to Earth, we have also classified them into three categories. Let's just quickly go through them because we have a lot to cover up as well. So basically, uh, let's just go ahead with the A10s. So A10s, they have an orbit, as you can see here. The blue line, basically the blue circle, that is the Earth's orbit, and the pink circle, that is the uh, orbit of A10s. So these A10s, they are basically these asteroids. They have an orbit less than of Earth, but they cross the orbit of Earth. As you can see here, that that pink circle there, it does cross the orbit of Earth, right? So yes, they pose a threat to Earth as well, because they cross the Earth's orbit at few parts. So a famous example is 99942 Apophis, which was said by NASA back in the year 2004 to 2005 that it might impact Earth in 2029. Basically the chance of that impact was around 2% or low, so it wasn't a major threat. But because we researched about them, because we know so much about asteroids, we came to know that yes, there is a chance that this asteroid might impact us. Okay, moving on to Apollos. So Apollos, they are basically bigger. Their orbit is basically bigger than that of Earth. Here you can see the green orbit is of Apollos. So these Apollos, they have a bigger orbit, but they still cross the orbit of the Earth. So even these Apollos are a threat to Earth, because even they can impact Earth. A famous one being Chelyabinsk meteor, and I'll tell you what the Chelyabinsk meteor was as we go ahead. And the next one and the final category being Amors. So as you can see, Amors have a much bigger orbit than that of Earth. Okay, but they do not cross the Earth's orbit. So what do you think? Do these Amor asteroids, they pose a threat to Earth? Obviously, no, because they do not cross the orbit of the Earth. So yes, they do. The Amor asteroids, they are not a danger, but still they are near Earth asteroids. And the famous one being 433 Eros. And yes, you guessed it right. We already discussed about 433 Eros, as it was the main target for NASA's near mission. Now, we have discussed about NASA's NEO mission. So let's just discuss about another mission carried out by NASA, which is OSIRIS-REx. So basically, OSIRIS-REx was a recent mission carried out by NASA. The full form for which is written here: the origins, spectral interpretation, resource identification, security, and regolith explorer. So basically, this mission was sent by NASA to a near Earth asteroid named as Bennu. The name of asteroid was Bennu. So what this mission has to do, they basically, it went there to the asteroid. It collected samples of the asteroid. As you can see here, it is mentioned regolith explorer. So it collected the soil of that asteroid, and now it is bringing it back to Earth. And maybe in a year it will be back on Earth. It is almost back. Okay, and we will have basically we will have samples from asteroid. Okay, so that is the importance of our job here. We are finding new asteroids in this Khagolshala Asteroid Search Campaign. Or basically, not we, you guys are finding new asteroids. And let's just say in the future, those asteroids will be the targets for NASA to send new missions to. So an asteroid you found will be the target for NASA's mission. That is such a huge opportunity. Okay, so moving ahead, let me just show you a quick video. As you can see here, let me just show you a quick video. As you can see here, you are seeing you should be able to see a lot of white dots, right? You guys seeing that there are a lot of white dots. Okay, so what are these white dots basically? These white dots are basically asteroids. Do not get confused by the size. The asteroids are much smaller than the Earth, but these white dots are basically asteroids. Okay, so these asteroids, you can see they are present in such a huge number, and only in the year 2016, in the year 2016, we found 1556 asteroids just in the year 2016, and every year we keep on finding hundreds of more. So even this year you guys will be finding a lot of asteroids. So that, and here you can see there are so many asteroids present, and there are nearly 14k asteroids which are present. Basically, till now we have discovered that there are 14,000 asteroids, more than 14,000 asteroids, which are closer to Earth. Okay, so moving ahead here, like I told you that we will be discussing about the Chelyabinsk meteor. So what was the Chelyabinsk meteor? So basically what happened, there's the city in Russia called Chelyabinsk. What happened, an asteroid which was the size of 20 meters, just the size of 20 meters. 20 meters is basically a room. Okay, the size of a room. An asteroid that big, it entered the Earth's atmosphere in the year 2013. Here you can see the video. So basically, what happened? This meteor, basically this asteroid, which is named as Chelyabinsk meteor because it entered the Earth's atmosphere, it got exploded in the Earth's atmosphere. Because our atmosphere, we should be grateful to Earth's atmosphere that this asteroid, it got burned up in the Earth's atmosphere. Okay, and even though it got burned in the Earth's atmosphere, it blasted in the Earth's basically above Earth. It blasted up there. And the impact, listen to this very closely, the impact created by this Chelyabinsk meteor, basically the blast impact up there in space, it was 30 times, yes, you heard me correctly, 30 times greater than the Hiroshima and Nagasaki atom bombs. Can you believe it? That was the impact caused by this Chelyabinsk meteor. So think about it. If that asteroid wouldn't have been burned up there in space, अगर वो एस्ट्रॉइड अर्थ पे भिड़ जाता, अगर अर्थ का एटमॉस्फेयर उसको कंप्लीटली बर्न नहीं कर पाता, व्हाट वुड हैव हैपेंड? the disaster would be huge. And even though it exploded up there in space, a lot of property was destroyed, and hundreds of lives, more than 100 of lives, were injured. Okay, so that is why we are researching more about them, so that in the future, if something like this happens, we can make ourselves safe from such asteroids. Okay, and so something happened around 66 million years ago. So what happened? Basically, there's a city in Mexico called Chuxuclub. So this city in Mexico, it is famous for its crater. There's a crater known as Buried Crater here, as you can see on the basically screen. So this crater was formed 66 million years ago. What happened? An asteroid which was the size of 10 kilometers. 10 kilometers. What do you mean by what is 10 kilometers? Basically, it was even bigger than basically the क्या कहते हैं, basically if that basically that asteroid, it was bigger than our Mount Everest. Since it was 10 kilometers, it was bigger than the Mount Everest. That asteroid, it couldn't completely, basically it completely couldn't get burned off in the atmosphere, because it was 10 kilometers. And I told you, any asteroid above 140 kilometers can will not get burnt in the atmosphere, and it will impact the surface of the earth. So that asteroid, it got impacted the earth. It was the size of 10 kilometers, and when it impacted the surface of the earth, at that moment, around the impact was so huge that around 75% of plants and animal life, they were obliterated. They completely wiped out the 75% of plant and animal life. And the remaining 25%, what happened? This asteroid, when it impacted, it started chain reactions. So there were a lot of volcanic eruptions, there were a lot of earthquakes, and the remaining 25% of plants and animal species, they were lost as well. Now you must think that okay, 66 million years ago, what were the animals living here back then? And I'm sure all of you have guessed it correctly. So yes, these animals were dinosaurs, and so they got extinct because of that asteroid impacting the earth. So if the dinosaurs can go extinct because of an asteroid impacting the earth, we as humans are nothing. So that is why we are researching more and more about asteroids every year. And this being the 11th year of asteroid hunting. Basically, this is the 11th year where we at space, along with the collaboration with IASC, basically the International Astronomical Search Collaboration. This is the 11th year for us. We have been conducting these asteroid search campaign here in India. We started back in 2010, and till now we have been going on, this being the year 2021, and so this being the 11th year. And over the course of time, over the course of 11 years, we have found, we have basically had a lot of achievements. So here are just a few of achievements, and see these achievements very carefully. Why am I telling you this? Because there might be one of you, two of you, three of you, or even 10 of you whose whose achievements will be listed next time we are having this campaign. So basically here are these few achievements. Two numbered asteroids basically. So what are numbered asteroids? The asteroids, we know that it is up there, we know an orbit of that asteroid. Then 69 provisional discoveries. So provisional discoveries are confirmed asteroids, that yes, we these asteroids are up there, but we do not know the orbit of that asteroid. Okay. Two special discoveries, basically the discoveries which are especially special even in the categories of asteroids. Then 7203 preliminary discoveries. So what do I mean by preliminary? Like when you will be going on with this campaign, you will be finding asteroids. When you find an asteroid, that will be declared a preliminary discovery until basically the IASC it confirms that yes, there is an asteroid. When it is confirmed, basically another image, like there's the telescope, right? So we have telescopes. So basically these telescopes, they keep on clicking pictures of the space. So until we click another picture and we basically find out that yes, this asteroid is present up there, it is a preliminary discovery. So when you find an asteroid, it will be a preliminary discovery. Let me just quickly tell you. So basically, I'm sure that all of you must have been given the kits, basically the Khagolshala Asteroid Search Campaign kits, which has a software, which has a few other things. So in the same way, you will be downloading, as my colleague Harsh will be telling you the whole procedure, how you will be downloading the data sets. So what are these data sets? Basically, they are sets of images. The images clicked by telescopes. Okay, so these images are of our sky. So these images, what you will do, using these images, you will have a set of 4 images. Okay, using these images, you will find asteroids. They are images of the sky, and so you will use that image in the software Astrometrica, and you will find asteroids. So when you find an asteroid, it will be a preliminary discovery. When ISC confirms that yes, it is an asteroid, then it will be a provisional discovery. Okay, and then when we find the orbit of that asteroid, it is a numbered asteroid. So basically these are the classifications as how the achievement goes on, and so you could be one of them, or for the preliminary, the provisional, or even the numbered asteroid. Other than that, we have achievements of 62 NEO confirmations and 1636 NEO observations. So what are NEOs? NEOs are basically near Earth objects. And I will tell you what are NEO confirmations and NEO observations just in a few slides. Okay, so just stay tuned. I'll tell you what these are. But before we begin, I have been telling you that we basically I have been telling you that have we have we will be getting basically pictures, right? I've been telling you we will be getting images which we will analyze using the software, right? So what are these images? So let's just see that what these images are. So these images are clicked by the Pan Stars Observatory. So basically there's this telescope named PS1 telescope. The observatory name is Pan Stars. Okay, so that observatory, it is present in Mount Halekla, which is in Hawaii, USA. All right, so it is a huge telescope and it has a huge collecting power. Basically the images it clicks are all are of a very high magnitude. Like, let me give you a very quick example. If you go in a very dark region and the sky is very bright, okay, it is a very bright sky, the faintest star you see, the star which is very barely visible, the magnitude for that star will be 6 at best. 6 magnitude. Okay, so how does this magnitude works? Let's just say in this night sky you see 2 stars. Okay, one is very bright and one is very fainter. Okay, so the brighter star will have a lower magnitude. So let's just say the brighter star will have 1 magnitude, but the very faint star, or the star which is very barely visible, it will have 5 or 6 magnitude. Okay, so the Pan Stars Observatory, or the PS1 telescope, it is able to click pictures of up to 24 magnitude. Can you believe it? That is the power of this telescope. Up to 24 magnitude. So we, with our human eye, can only see up to 6 magnitude of basically stars up there in the sky. But this telescope can click pictures of objects up to 24 magnitude. Okay, so what this does, this PS1 telescope, it clicks images of the night sky every 15 minutes. So every 15 minutes it clicks one image, and then the next 15 minutes it clicks another image, and the next 15 minutes another, and then another. So basically when it clicks 4 images of the same sky, basically the telescope is moving along with the sky. Okay, because the sky is moving up there, right? Basically the earth is moving, so the sky changes its position up there, so the telescope is also moving along with the sky. So every 15 minutes it clicks up image, and when it clicks 4 images, that is our data set. Considering I have been saying this word data set a lot, so that is what makes a data set. A set of 4 images clicked by the telescope, and that is what you will be getting. That is the data set you will be getting. It is a collection of 4 images. Okay, so that is the data set. So let's just quickly go ahead with the part that what happens during this entire program. So as I already told you, the PS1 telescope is used to take images of the night sky, which I already told you. It will be taking pictures every 15 minutes, and when it takes a picture of 4 pictures every 15 minutes, that makes a data set. The images are processed and made available to the students, which are you. Basically the images will be given to you, the set of 4 images which are the data set. The students will download the image and analyze it with the software Astrometrica and find the moving objects. So what are these moving objects? Okay, so what are these moving objects? So basically these moving objects, they have a high probability of being an asteroid. So how you will be finding them? Because here it is written that you will be downloading the image set and you will be analyzing it with the software. All information, each and every information will be given to you. Don't worry about it. Do not get stressed about it that, oh, sir is telling that, okay, we have to download, but he is not telling us where we have to download it and how do we have to use Astrometrica. Every information will be given to you, so don't worry about it. Right now I am telling you this so that you have a basic idea. In detail we will be going on as we move ahead. Okay, so and then finally after analyzing, the students will upload the report based on their analysis. Okay, so I'm sure all of you are clear with this concept that how this works, and don't worry, as I said, every step mentioned here will be explained to you completely and in a very organized manner, so don't worry about it. All right, so how does the process of discovery works? Basically, because I have been told I have told you the what are the achievements which we have conducting these campaign for the past 11 years. So basically how this works is that when you get a data set which is a image of which is a set of 4 images, you use the Astrometrica software to run those 4 images. When you find an asteroid, okay, when you find an asteroid, you send the report. When you find a moving object, you send the report to IASC. When that report is sent, IASC declares any new asteroid as preliminary. Preliminary, why preliminary? Because it is not confirmed yet. Okay, then what it does, IASC asks Pan Stars to take a follow-up image of the discovered asteroid. So basically the Pan stars, it is supposed to take another basically the Pan stars, it is supposed to take another follow-up image of the discovery you made. Let's just say you got a image set. The image set has 4 images, right? As I told you, open Astrometrica, you analyze using Astrometrica, you find an asteroid, you send the report. ISC says that okay, it is a preliminary discovery. Then ISC asks Pan stars to click another image of that object. When the another image is taken, it is now confirmed that it is an asteroid, so it will be basically it will be recognized as a provisional discovery. Okay, because now when the image is taken, it is now confirmed to be a provisional discovery or a confirmed asteroid. But let's just say the image is not taken or it is not found to be an asteroid. So what happens? It is not like that all of your credit will be lost. That okay, I did this campaign and I had nothing, like I got nothing. No, it won't be like that. You will still have the achievement of the preliminary discovery at your name. No one else can have that credit. That credit is only yours for the preliminary discovery. Okay. And if another follow-up image is taken, the asteroid is confirmed, it will be a provisional discovery. All right. So how does this basically the provision from provisional, it gets changed to numbered asteroid. So basically what happens is when the follow-up image is taken and it is a provisional asteroid discovery, what happens, we our work is not done yet. Why? Because now we know that okay, there's this asteroid up there, but we do not know how is this asteroid moving in the solar system. So for the next 5 to 6 years, basically it takes 6 years to find the orbit of the asteroid. And when the orbit of that asteroid is found, when the complete orbit is found in 6 years, the provisional asteroid discovery, it changes to numbered asteroid discovery. Okay, so here you must be seeing a lot of MPC written everywhere. So what is this MPC? So MPC is basically the minor planet center. Okay, so what does this do? Basically the minor planet center, it records basically all the discoveries made by you from the basically when you get from the preliminary discovery, like when ISC says that okay, this is a preliminary discovery, and it confirms that no, after the follow up image it confirms that no, it is a provisional discovery, that yes, there is a asteroid up there which you guys found. Okay, so then the MPC, the minor planet center, it records that provisional discovery, that yes, there is the asteroid by so and so name, found by so and so, like your name. Okay, and so the MPC, the minor planet center, it catalogs all the basically the data for this asteroid, that yes, there this asteroid has been found. And over the course of years, when say after 5 to 6 years, when the orbit of that asteroid is found, the MPC records it as numbered asteroid discovery. Okay, and it is given a permanent name or a permanent designation, which you have the opportunity to give. Yes, you can name the asteroids. You have the opportunity to name the asteroid. So think about it in such a manner. There will be an asteroid moving around in space, an asteroid you found and an asteroid you named. Can you believe it? That is such a huge achievement. That is such a proud moment, I should say, that you named an asteroid, you found an asteroid, and that is going around up there in space. Okay, so that is the importance of this search campaign. Okay, so so that is how the basically it changes to numbered discovery. Now, as I already said, that basically ISC, when you from a data set you find an asteroid, and so ISC clarifies that it is a preliminary discovery. ISC asks pan stars to take another image, right? So when Panstars takes another image, that data set, that data set basically is given to another students. Like let's just say today you find an asteroid, okay, using the data set given to you by ISC. You send the report back to ISC. ISC sees that okay, yes, it seems like an asteroid, so let's just give the a preliminary discovery. Then ISC asks Panstars to click another pictures of the click another picture of those asteroids. That second or the follow-up image which is taken by Panstars is given to another student, let's just say, and that another student finds the same asteroids which you found. So you will be getting the provisional discovery, right? And the another student which found the same asteroid you found, considering it is the second observation, he will be getting the achievement for NEO confirmation, because he confirmed, he said, The second time he saw that, okay, yes, there is this asteroid present there. So he confirmed. So he will be getting the NEO confirmation achievement, and you will be getting the provisional discovery achievement. Okay, so are we clear? But that is not done, since that our work is not done yet, because I said na, because we will be researching about that asteroid for the next 5 to 6 years to find the orbit of that asteroid. So Pan-STARRS takes more and more images of that asteroid, and sends these if more images to more students. So when these students in the third and fourth observations they find the same asteroid found by you, they will be given the achievement for NEO observation. And after 6 years, let's just say when the orbit is found for that asteroid, you will be given the achievement for numbered discovery. Okay, so that is how the process of discovery works, and this is very important. Why is it very important? Because all of these steps, each and every, the NEO confirmations, the observations from the preliminary discovery to the numbered discovery, every step is recorded by JPL NASA, basically the Jet Propulsion Laboratory. Because the Jet Propulsion Laboratory, NASA, it is constantly using this to update their near Earth objects database, because they have to send satellites up there in space. Basically, they have to send a lot of missions up there in space, so they need to know each and every objects, near Earth objects which are present up there. So think about it. Every discovery you make, even if it is NEO confirmation or NEO observation, the second and third observation, that is also recorded by the JPL NASA, and you will be having that achievement at your name. Can you believe it? So yes, this is a huge moment for all of you. Okay, so now I have been saying a lot that we will be given a set of basically four pictures, and using those four pictures we will be finding asteroids. Now you must be thinking that how can we find an asteroid using pictures, because it is just an image, so how will we find asteroid in them? So let me just give you a quick example that how do we do that. So here you can see two images. Okay. So in these two images, can you find the differences? Like, let me just say, I'll give you 10 seconds. Okay. I'll give you 10 seconds and let's see how many of you can find differences between these two pictures. Okay. So I'll give you 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so 10 seconds are up. I'm sure a lot of you must have found one differences, two differences. Some of you might have also found four or five differences. But anything above that is very hard to find. Why? Because because basically we, our human mind can only work so fast. We have 10 seconds and we have to find differences between these two pictures, but we only have 10 seconds, so the time is very short, so we cannot find all the differences between these two pictures. So how do we find more differences in these two pictures? Well, we make our lives easier and we use a process called blinking. So what we do, we run both of these images. So ये दोनों जो images हैं, we run both of them at a speed. Okay. So basically we set a speed and we basically move both the images at the same time. So here you can see the first image. Here you can see the second image. Can you see how they changed? Here, see. See how they change. You see? So I'm sure when we blink both of these images, all of you can clearly see how many differences are present there. See? Here you can see. So that is the process of blinking. We run these images at a speed. Basically, in our case, we will be having 4 images. So we will run all these 4 images at a speed, and any moving object or any change in that image will be visible to us clearly. So that is how the process of blinking works. Okay, so are we clear about that? All right. So here you can see, basically how an asteroid is located, because here you must be seeing on your image, or basically on your screen, that there's this asteroid which is moving, right? So this is nothing, this is basically, these are 4 images which are running at a speed, okay, which are running at a speed. And so when this asteroid is moving, because as I told you, the pan stars is clicking images every 15 seconds, right? 15 seconds. Since these stars, all these brighter and bigger objects you see, these are stars of the night sky. So these stars are very, very far away from us, right? They are very far away. So they do not change their positions up there in the sky. And since our telescope is moving along with these stars, any other object which is closer to Earth, like these asteroids which are closer to Earth, they will be visible that they are moving. So here you can see there are these four images, basically they are blinking together, and you can see that this asteroid is moving, and all the other objects, which are the all the other stars and other celestial bodies, they are stationary. So that is the process we use basically to find new asteroids, and in detail we will be going through all of it as we move ahead. All right, so let's just quickly discuss about our organization space. So basically we at space, we are constantly working toward the scientific development of the community of our country, as well as at an international level. We have been conducting this asteroid search campaign for the past 11 years. All right, we have been conducting this for the past 15, basically for the past 11 years, we have been conducting this asteroid search campaign. We have been conducting specialized workshops and training students on astrometrica. So basically we are training each and every one of you, we will be training each and every one of you uh, on the software Astrometrica as we go ahead, and where you will be using the data sets to find new asteroids. We have been providing 24/7 technical support throughout the campaign. So throughout this campaign, as this campaign goes ahead, moves ahead, we will be providing you all the help you need. Any problem you come across, you can contact us and we will be there to help you out. And then we are felicitating the asteroid discoverers, which are you. Okay, which are you guys. We will make sure to felicitate you. How do we do that? We will bring you opportunities, we will bring you a lot of interactions, we will give you a lot of interactions. We will be giving you opportunities to meet a lot of influencers, a lot of scientists, not only in India, not only in India. You will have the opportunity to meet scientists and influencers throughout the world. You will have the opportunity to get recognized throughout the world. You will have the opportunity to be recognized by NASA and other space agencies which are present in the world. So yes, it is a very big opportunity for all of you. So this year we are conducting the Khagolshala Asteroid Search Campaign in 2 phases. Okay, so phase 1 is from January 6th, which is upcoming, to January 31st, and phase 2 will be from February 4th to March 1. Okay, so I've been saying that we will felicitate you and there will be a lot of opportunities. So what do I mean by that basically? So what this campaign brings to you, like when you find an asteroid, see what basically the exposure this campaign will be giving you. You will be in the news, you will be having newspaper interviews, you will be having news channel interviews, you will be having a lot of reporters which will be after you to take your interviews. Why? Because you have found a new asteroid. Let's just say you find a new asteroid, and that is such a huge deal for NASA and other space agencies, because the amount of scientists which are present in the world, they are very low, and the amount of asteroids which are present in the world, basically in the present in the space, it is very high. So when you find it, we will make sure you get the right exposure, you get the international exposure, you will have the opportunity to participate in a lot of international basically a lot of international competitions after this as well. NASA and other various space agencies will recognize your name, and you will get a lot of exposure in a lot of news channels and newspaper interviews as well. So how proud moment, think about it, how proud moment it will be for you, your family, and everyone close to you, because your name will be portrayed by NASA, your name will be in the newspapers, your name will be in the news channel interviews. Talking about interviews, here is a short video. Basically this interview was taken for one of our students who found an asteroid, and so Lok Sabha TV, it made sure to take the interview of that student. So just watch this short video here quickly.
दिल्ली के दो छात्रों ने पिछले दिनों आकाश में एक एस्टेरॉइड की खोज की है। ये एस्टेरॉइड एमिटी स्कूल में पढ़ने वाले शौर्या चांबियाल और गौरव द्वारा खोजा गया है। मैंने एस्ट्रोनॉमी 8 साल की एज से शुरू की थी और मैंने एस्ट्रोनॉमी बुक्स के थ्रू, चैनल्स, नेशनल ज्योग्राफिक और नासा की साइट के थ्रू पढ़ना शुरू की। और जब मुझे पता चला कि हमने एस्टेरॉइड ढूंढा है तो गौरव और मुझे बहुत खुशी हुई और हमने सबको मेल भी किया कि हमने एस्टेरॉइड ढूंढा है। बच्चों की इस खोज को इंटरनेशनल साइंटिफिक कम्युनिटी ने भी अपनी मंजूरी दे दी है, जिसके बाद वैज्ञानिक समुदाय ने इसे 2013 LS28 नाम दिया है। दोनों के छात्रों ने ये खोज पिछले महीने शुरू हुए ऑल इंडिया एस्टेरॉइड सर्च कैंपेन के तहत की है।
So you see that exposure we bring to you, the exposure this campaign brings to you. You will be getting such new, you guys have the opportunity to get interviewed, to get your face on the television by discovering by discovering an asteroid. So not only you will be doing a huge help for the scientific community of the for the entire world, you will also be having these opportunities to be portrayed by NASA, to be portrayed by other various news channels and newspaper articles as well. And that is not all. That is not all. That is not all. You will be having a lot of opportunities to meet various prominent scientists, prominent influencers, prominent basically researchers for India as well as space. Here you can see that all of these are all of our students basically, and they met so many other public celebrities or scientists who are constantly working for the development of the scientific community for the world. As here you can see, basically these are our students for the year 2016. After they discovered the asteroids, they had the opportunity to meet with Dr. M. Anandurai, who is the director of ISRO Satellite Center. So yes, ISRO Satellite Center, he is the director, and they had the opportunities. They were students just like you. So if they can do it, so can you. So even you have the opportunity to meet such prominent scientists, and not only at a national level, not only in India, you have the opportunity to meet international scientists as well. So here you can see basically these are our students who found basically their discovery was classified afterwards as numbered discovery. So they were congratulated by Dr. Andrew Robles and Dr. Paul A. Rawson, who are scientists at NASA JPL, the Jet Propulsion Laboratory, NASA. So you could be the next person in this picture. You could be the next student who makes India proud and who goes to an international level and is recognized by the international society. All right. So, who wants to be an asteroid discoverer? I am sure all of you, right? I am sure each and every one of you want to be an asteroid discoverer, right? So, with this, I'll be signing off. I'll be handing over this to my fellow colleague Harsh, who will be giving you the training on the technical part and how you have to download your data set, how you will be using the software Astrometrica, and how you can find the asteroid for yourself and make India proud, make yourself and your parents proud, and get recognized by the international scientific community. All right, so this is me, Aditya Jaiswal, signing off, and I wish all of you luck, good luck, and happy hunting. So, Harsh, with this, you can take over. Harsh.
Mm-hmm.
I'm
I'm
listening.
listening.
Okay, so with this, Harsh will be taking over.
Yeah, fine.
Fine.
Okay.
Okay.
So,
So,
hello,
hello,
astronomers.
astronomers.
First of
First
all,
of all,
thank you,
thank you,
Aditya,
Aditya,
for
for
enlightening
enlightening
us
us
with
with
your
your
knowledge
knowledge
on
on
asteroids
asteroids
and this
and this
campaign.
campaign.
Before
Before
starting,
starting,
I would
I
like
would
to
like to
ask,
ask,
are you
are
all
you all
bored
bored
or are
or
you
are
all
you all
enjoying this
enjoying this
campaign?
campaign?
Because I
Because I
think it
think
has
it has
been
been
since
since
1 hour
1 hour
that we
that we
started
started
the
the
theoretical
theoretical
part.
part.
Now,
Now,
if you are
if you are
feeling
feeling
sleepy,
sleepy,
you can
you can
just
just
have some
have some
water
water
or you
or
can
you can
ask your
ask your
mom
mom
to
to
have you
have
a
you
cup
a
of
cup of
coffee
coffee.
because
Because
soon
soon
you are
you are
going
going
to
to
get
get
famous.
famous.
Soon
Soon
you are
you are
going to
going to
be
be
a
a
mature
mature
scientist
scientist
by
by
discovering an
discovering an
asteroid.
asteroid.
You are
You are
getting a
getting a
chance
chance
where
where
hardly
hardly
someone
someone
knows
knows
what
what
is an
is an
asteroid.
asteroid.
Here
Here
you
you
are
are
sitting
sitting
now,
now.
who
Who
knows
knows
everything
everything
about
about
asteroids,
asteroids?
and
And
that
that
not
not
only
only
this,
this,
but
but
you
you
also
also
know
know
how
how
to
to
search
search
for an
for an
asteroid
asteroid
in
in
this big space where you can see millions of astronomers. Here we begin. Hello, astronomers. There is more to this asteroid discovery part, and that part is that part is waiting for you. Okay, so here we begin again. Hello, astronomers. Good afternoon. My name is Harsh, and I hope you are enjoying the training on asteroids, and that by now you are very clear with the word asteroid. Like, what are asteroids? What are they made up of? How big they are? Where do they reside? And why? And why is it important for us to study about the asteroids, right? Then we talked about what is KASC all about, what has been our achievements, and how it did it. And now is the next part, how to use the Astrometrica software to actually look for the moving objects. Okay, create a report of it and submit it to IASC so that uh, yeah, and submit it to IASC so that they can check whether it is a confirmed discovery or not. So here we begin. So the major steps of these are as following. I hope my screen is visible to every one of you. Okay. Yeah. So the whole process is going to take place in just 3 steps. Now that you are aware what is an asteroid, where do they reside, and everything, now you have to do the practical part. That is actually going to search for an asteroid. The data set which has been sent to you by PS1 telescope. You are now going to analyze those in just 3 steps. You have to remember these 3 steps because this is how you will be doing it. So, starting with the first step, that is downloading the dataset, which means from where will you get the data set? For that, you have to download the data set from IASC website. Okay, the website will be sent to you in the mail ID, or else I'm telling you right now, the link is iasc.cosmosearch.org. I'm sure you would have received it in the mail ID. Okay. Now, when you go on to the page of that, you have to simply download login into your account, and then you have to download the dataset from there. Now you have to remember one thing. Now that is, when you are downloading the dataset, it will be in the form of a zip folder. So what you have to do, you have to simply unzip that folder and save it with the same name. Now that's done. You have the data set in your computer. What's next? Coming to the second step, that is analyzing those data. Now, when you will open those data sets, basically you will have four files over there, which Aditya would have told you. Those are basically the images of the sky, which are taken at an interval of 15 minutes. Okay. So those are the images which you are going to analyze now over the software Astrometrica. So using the software Astrometrica, you have to detect for the moving object, which can be an asteroid. Okay. And there is nothing else you have to do. You have to just simply search. You have searched for an asteroid. You just give it a name, whatever you like, create a report of it. And then comes the third step, that is submitting the report to IASC. Now, while submitting the report, you have to remember that you are using the same website from where you downloaded the data set. That is the IASC website. I am again repeating the link of it. It is iasc.cosmosearch.org. Okay. Now, I will tell you each of these steps in detail as how you have to perform it. So, coming to the first one, that is downloading the data. Okay. So, here on my screen, you can see, just a second. Yeah, over here. You have to go on to the website of iasc.cosmosearch.org, which I told you. Okay. Once you enter, you land onto their page. This is how it looks like. Okay. Once you get over there, campaign session. Now, what you campaign, and it shows which are running right now. Before I continue, I will don't have to worry if you forgot any steps. This video will still be there on the YouTube. All you need to do is simply like the video and subscribe it, or you can also share it with your colleagues. This video will be there on the YouTube, and whenever you desire for, you can simply go on to the YouTube, open this video, and again check the process as how I did it. And I'm sure that there won't be any problem you would face while doing these all steps. Okay, so let's continue. When you have opened the web page of IASC Cosmos Search, then you go on to the campaign, and this is all the campaign which are listed below. Okay, now that our campaign has not yet started, but you can see the name of International Asteroid Search Campaign. So just like that, you will have the name of Khagolshala Asteroid Search Campaign. Then when you tap on it and scroll down, as I did, you can see the team names it's written over here, right? These are all the teams all over the India, or you can say all over the world, who are participating in this campaign. So think you are working on an international platform with majorly all the students, scientists, and every age person. Okay, so this is what you are getting now. That, yes, as you scroll down and you can see all the team names listed below. Okay, from this you will have to search for the names of your team. The team name would be given to you by us. Okay, let's say I registered it with my team name, and my team name was Space India. So I simply search for Team India, as you can see over here where my cursor is right now, and you simply click on it. Okay, and this will open. Now what is it asking for? Login. I told you it will ask for login. So can you guess how you are going to log in? Do you have the email or the password? Okay, I will tell you. The email I am using here is my email, okay, from which I registered. What you have to use it is that the ID by which you registered. Okay, in this campaign, you might have registered or you might have given your own particular email ID. So you have to use that same over here. Don't use anything else apart from that. Else, it won't be accessible to you. Now, that is done. Uh,
Okay, so I'm sorry, there are some technical difficulties we are facing at Harsh's end. Just give us a moment to resolve. Okay, so Harsh, your audio is basically not, basically it's not connected, or it's not audible. So can you please check that, Harsh? If all of you can give us just a moment, just a minute, we'll just correct this and get back to you. Okay, so yeah, I'm being told that he is reconnecting. Okay, so things like this do happen, but I'm sure that till now, whatever he explained to you, I'm sure that all of you have been able to understand it clearly. That basically how is it working and what we are doing. Okay, so Harsh is back here with us, I think, and so he will be taking over once again, and let's just give him a second or two so that he can settle himself once again, because when these technical issues occur, things like these do happen, so it's fine. But I'm sure that till now, whatever he explained, that how you have to go to that iesc.cosmosearch.org, and afterwards what you have to do, you have to log in and go to the campaign section and find your team. Okay, so I think Harsh is connected now. Harsh, just turn off on your mic and you're good to go. Okay.
Thank you, Aditya, for taking over.
Yeah,
I'm
no
sorry,
worries.
friends, there are some technical issues as such. Let's continue. I think the steps still here are clear to you. That is how you are going to get your email ID or what you are going to use, or the password. That is what you are going from what you are going to get from IASC. Okay. Now, once you type your password, let me type what I have got from IASC and click on login and scroll down. Now you can see the datasets listed below. From here, you will download the datasets by tapping onto download. If you can see my cursor on the screen, this is the image dataset which you are seeing on the screen. The PS1 2019 P10. The same way you will also get the datasets in your account of IASC after you have received the password, because you are going to use the same ID. I'm again saying you are going to use the same ID which you have used while registering. Okay. Now When you will tap on this particular blue icon of download, that particular image set will be downloaded on your computer and a tick mark will be appeared just beneath the place where it is written downloaded. Now, you can also be seeing that there is a complete tick mark on each dataset. This means that in my computer, in my account, I have downloaded all the datasets. Okay, that's why there is a tick mark on all of them. Once you download one by one, the tick mark will gradually occur. Okay, and are you also able to see there is something written like submitted, report submitted, and a tick mark over there, the first one. Now, what is it? Okay, I will tell you. Uh, yeah, what happens is the same page will be used to submit the report. I told you again before. Again, I am telling you the same page will be used for submitting the report. And when you will submit it, a tick mark will again come beneath the report selected. Okay. Now, how will that happen? How will you submit the report? I will tell you later on. And when you would have analyzed, yeah, now these are all showing on my screen because the campaign has not yet started. Okay. Once the campaign is live, you can see it on your screen. Now let's scroll down. Just a second. Yeah. Can you see over here on my screen? It is written as submit an MCP report, image sets. So this is the place from where you have to, while submitting the report. Let me clear it again. While submitting the report. Yeah. When you have downloaded the particular dataset, analyzed it, and you are going to do the third step, that is submitting the report. What you are going to do is from here, the drop down menu over here, you have to tap on it and you will get all the datasets which are available to you. Okay, listed below. You have to simply click on the dataset which you have analyzed, and that's it. Do remember that you have to select the right data set for analyzing that, and also over here. That means, let's say if you have analyzed the PS1 201 data set, so you have to set over here, you have to select the same data set. If you select something else and you have analyzed any other data set, so your discovery won't happen and you will generate a false report. Is it clear to you? Fine. And also, you might be seeing over here at citizen scientist. That is your data set. How you are going to do that? I will tell you clearly further. So what you are going to do next is you go to the location. Let's say I have downloaded all the data sets. Okay. The same way you are going to download your data sets. Let's say you have downloaded any particular data set on your computer. So you have to do what next is you go to the location where the data set is stored. You can either extract it over there or you can copy and then paste it on your desktop so that it can easily be found. Okay, let me do that for you and show you each step very clearly, so that I think you don't face any trouble while doing so or following my steps on the YouTube. I'm again saying, please do like and share our video so that you can easily get access to it. Okay. Now, yeah. Now you can see that I have pasted the report on my desktop. Okay. Once you paste it over there, you right click on the folder and you will see the option of extract file, the second option, right? So simply click on the extract file and then click on OK without changing anything. Now you can see the folder would be there on your screen over here. As you can see, this was the particular dataset which I extracted and it's in the form of folder now. That means now you can open it directly. Okay. Now, when you will open this folder, you will get those 4 images in this. That is your dataset. Those 4 images, again, I am repeating, are the images of the night sky taken by PS1 telescope at an interval of 15 minutes, which you have to analyze in Astrometrica software to search for an moving object. Now, before doing so, you have to remember some points which are extremely important. Now, what are those? Hmm. Yeah, yeah. Now, when you are doing this whole process, that is when you are downloading dataset, analyzing the dataset, you have to remember some points. That is, each school will get its own image datasets to analyze. Now, it is important that you do not analyze the set of any other student or any other school, only those that you have been given into your account, because even if you do so, you select any other person's particular data set and you analyze it, you won't get any credit for that. Okay, so it's just a waste. try to do Try to search for the discovery which in the data set which you have got. Now, the second point, and that is the image sets are uploaded in orders. That simply means that if your school does not currently have any image sets to analyze, that is, when you logged in and you see that your folder is empty, you don't have to worry. Be patient. You are next in line. You will soon get the data from IASC. There is sometimes delay from their side, but it's okay. Okay, either in this process, if you face like, sir, you still didn't get the query, didn't get any data set, or you have any queries, you can contact us. The contacts will be shared with you on the email, and I will also tell it at the end of this presentation. Okay, so let's begin. There is also the third point, and that is, if you do not participate in this event for a longer time, that is, you have got the data set and you are not analyzing the data set and submitting the report on time. Okay, then that data set will be deviated to other school folders and you will lose a chance of being an asteroid discoverer. So make sure you are actively participating in this campaign. The data sets will already be started to be getting you by 6th. Okay, that is at the start of the campaign. The first dataset which you will get by IASC will be a practice dataset. Now, what is the importance of that? I will tell you further. You have to analyze each dataset by that day or within 3 to 4 days. Make sure that you do it on the same day, because by doing this, you get the chances of being a discoverer at a higher rate. And if even if you do it at a 3 to 4 days, it's okay, because the chances of being an asteroid discoverer will be very minimal. So please try to analyze the data on that same day or just the next day. If you have any query, again, we told you that we are here present for you 24 into 7. Okay. Now that you know how to download the data sets, right? You have downloaded the data set from the IASC website. So the second steps come, that is Astrometrica. I told you at the beginning that the whole process is going to take place in just 3 steps. The first one, downloading the dataset, and the second one, IASC, using the software to analyze the data. So what's next is, how are we going to download the Astrometrica software, or from where are we going to get that? Okay. So Aditya might have told you that at the beginning, or by now you would have received the kit from us, that is your KASC kit. Okay, now once you open on that, and you can see this is how it looks like. Okay, it will include 4 options over there. Yeah, so when this campaign will begin, you will get a link from which you can download a kit. By now I think you would have got it, and that is your KASC kit, which will have the support guides. As you can see, the support documents, the setup file, that is that contains your Astrometrica file. That is the place from where you are going to download the Astrometrica. Okay, and other health material for you, which you can refer to, learn and understand how all about the campaign and how to use the Astrometrica setup. Okay, now once you click on the setup file, the first one, as you can see over here, Okay, I clicked, and you can see it is there, the Astrometrica setup. Now, this is the place from where you are going to download the Astrometrica file. I am again repeating, the Astrometrica file you are going to get from the link which we have sent you. That is your KASC kit. Please go onto your email and check once again. You might have received these. Okay. So once you click on that, the process is simple. Simply click on yes. Click on next, and it will start installing your Astrometrica software. Now, here is one thing you need to remember. Once installing, it will ask for you to the designation folder. Make sure that you do it in the C drive. Why I am speaking that you should do it in the C drive, I will tell you further on. Okay, but before that, make sure you are doing it in the C drive. If there is anything else present over here, please go to the browser session and simply change the folder to the C drive, and that is the place where your Astrometrica will be saved. Now click on next, and the installation file will soon happen. Now once done, it will ask finish. Click on finish, and the command prompt will be open, as you can see on my screen right now. Okay, click on any key to terminate the setup. Once done, now the Astrometrica software is installed in your computer, as you can see on my screen. Let me go back and show you again. Yeah, yeah. Can you see the Astrometrica on my screen over here, with the blue icon written Astrometrica? I have installed the Astrometrica on my screen, and that is how you will get it on your screen. Now, what's next is that once done, open the Astrometrica software. Okay, that is installed on your computer, and you can see the option. Yeah, once you double click on that particular icon of Astrometrica, it will try to download the database folder, as it is happening on my screen right now. Okay, now why is it important? I will tell you. Now, this dataset is required for the Astrometrica software to analyze the images. Okay. Now, how long will this process take? Depends completely on the internet you are using. Okay. So don't worry. It will happen. It will take its time by its own pace. Just be calm. Don't rush, and please do not press any key in this process or try to close the setup. Okay. Database. So database formation, asteroids, and other stars. And those images, when you will be that, let's say that is you are downloaded any particular data set and you are analyzing any particular images. So those images in the Astrometrica software will actually be analyzed with reference to this, yeah, to this database. So this is why this process is very, very critical. Okay. This database needs to be downloaded properly and the installation has to be clean. If that doesn't happen, you will not be able to analyze the images properly. Astrometrica will give you some or other errors. So the discovery will not be able to happen. And I hope that you don't want this to happen. So let's wait for some time. 60% almost done, and the Astrometrica is about to open. So within few minutes, and this database will be downloaded. After that, I will take you to the tour on how the Astrometrica software, on how to actually use the Astrometrica software to analyze the images provided to you by IASC. Now you can see on my screen that Astrometrica has been installed on my screen, right? Is it visible to you all? You can write it in the comment section. Even if you face any query, do mention that, sir, this particular step is not clear to me. Please explain me again, and I am here for you. Or what else you can do is, this video is available to you. Please, you can directly go back and watch this video again and again and do the process simultaneously later on. Okay. And you will not get any problem. I make sure. Even if you get, we are here. Okay. Now, once the download is complete, Astrometrica will open up. Okay. Automatically, it will do its process in the background. Let it do. And once that is done, it might give you a dialog box that is over here that would ask for mpc photoreport.txt, and Astrometrica log already exists. Replace existing file. You have to do nothing but click on the yes icon over here, as you can see. Okay, and that is done. Now, once done, you can see the Astrometrica on my screen. Yeah, once that is done, you simply close the Astrometrica. Shocked? Now, why did I close it? Why didn't I run the images directly? Next step, from now onwards, whenever you have to use the Astrometrica, you will never open it from your desktop. The reason being, whenever you open it from your desktop, it automatically downloads the latest database, and you don't have to update the database every day. Okay, you might need to open the Astrometrica 3 to 4 times a day, and updating a database 3 to 4 times a day is not at all wise. It will take your time and it's just unnecessary. I think you might have seen that it almost took our 3 to 4 minutes. So please don't do that. So the question might be there in your mind, but sir, how are we going to open then Astrometrica again? That you have closed it and you are saying that don't open it from your desktop. So how are we going to access it? It's very simple. So that's why there is another way using which you can open the software. How do we do that? I'm showing you. Simply take your cursor to the My Computer, which will be present on your desktop. Once open, I told you, remember that why you are downloading the data, sorry, the Astrometrica in the C drive. Now, what was its importance? I am showing you over here. You took it to the C drive and you can see Astrometrica over here, right? That was why I told you to please make it sure that you are doing it in the C drive. Once done, open the Astrometrica file and you can see over here to the sixth or seventh places that there is an astrometrica.exe file present with a blue icon. Okay, just click on it and the Astrometrica will again start up. Let it do its processing in the background. It won't take that time which it had taken at the beginning while updating the MPC report. That was enough. How many of you are getting this steps clearly? Please do mention in the comment section so that I can understand whether I am being sure. I would. Well, let me go back and continuing from here. I told you, I think it was very clear to you that why I told you to close the Astrometrica software, why I did, and now that I am going to tell you how you are going to open the Astrometrica setup on your computer, but that not from your desktop. Okay. So I told you that when you will be installing the Astrometrica setup, you have to make sure that you are doing it in the C drive. Okay. The reason being, when you open the C drive in my computer, you can see Astrometrica very clearly on the first place. It is easily accessible to you. That's the reason why we installed it in the C drive. Click on the Astrometrica file and you can see over here at the seventh place the Astrometrica file with the blue icon. Directly click on it and the Astrometrica will open. Okay, let it do its process. It might not take that much of the time which it had taken at the initial steps. Just wait for some minute, have some patience, and it will be done. Okay, it's almost done. Okay, now tell me how many of you are getting my steps very clearly. Please do mention it in the comment section as I can see all of your comments. Yeah. If not clear, please follow our video again. You can follow it as many times you can. Okay. Just you need to do is subscribe or like the video and it will be visible to you all the time. Now, getting back, this is how your Astrometrica will look like. Ah, it seems to be boring, right? Sir, what is that? It's completely blank with just some few tabs. How are we going to do that? Well, I will tell you. Be patient. When your Astrometrica will open, there are some few points which you have to remember. Okay? That is, before analyzing any data set, you have to change the configuration of this particular software. How you are going to do that? I will show you. Can you see on my screen the right hand side where my cursor is? It is written ps1.cfg. Now, what is it? It is basically the telescope configuration, okay, by which help we are going to analyze the data set given to us by IASC. Do you remember the name of the telescope that was in the Pan Star Observatory of Hawaii? It was PS1. Okay, and that we are getting the data set from IASC and it's using the PS1 telescope configuration. So the same configuration we have to use over here while analyzing our data sets. Do remember, if it is anything else apart from ps1.cfg, do change it. Else, your report may be false. Okay. Now, how you are going to change it if there is something else apart from ps1.cfg? Follow my steps. It is very simple. You just have to take your cursor to the setting icons below the file, the blue color over here. If you take your cursor, it's writing edit program settings. Click on it, and over here you can go to the programs. Okay, sorry, you can simply click on open, and from this you have to go to the same place where you downloaded the whole Astrometrica. That is the C drive. So again, select my computer, scroll down to the C drive, open it, go on to the Astrometrica, and you have got over there settings, right? You can see on my screen it's written settings. Is it visible to everyone? Please write on the comment section. Is this step clear to everyone? Can you now go to this setting and search for it? Then let's move and you will see all the telescope here. The name of it. Yes, if I hide it with my cursor, it won't tell me what was the telescope or the observatory by which help we are getting these images data set. I would like to see the first student who is brilliant in answering this, and the first one who answer it instantly in the comment section. Okay, so what we were using is ps1.cfg. So simply click on it, select the file, click on open, and once done, click on OK. And your ps1.cfg will appear over here. Okay, I think the steps are very, very clear to you over until here. Now comes the second configuration, that is over here where my cursor is right now. Can you read something? It is written ppmxl. Yes. Now what is it? Sir, beforehand you told me that it was ps1.cfg. That was the telescope settings. Now what is this ppmxl? Well, that is the star catalog which we have to use, okay, for our reference. Okay, if there is anything else present on your screen when you open the software apart from ppmxl, you have to change it. Make sure you do change it, okay, else you might not generate a proper report. Now, how you are going to do that? Once again, the same step you have to follow. Take your cursor to the editing file, that is the blue color beneath the file, click on it, but this time you have to go to the programs file. Once you take it over there, you can see it's written over here the star catalog. Is it visible to everyone? Yes, please write in the comment section. Is it visible to everyone? Yes, fine. I can see your comments. Very good. So I think the steps until here is clear to you. Let me explain once again for you so that it is by hearted to you. I'll again close it and I'll again explain it to you. You have to change this star catalog. How you are going to do that? You have to take your cursor to the same settings, click on programs, and you have to search for the star catalog. It's present on your screen on the right hand side, the first point over here. Just select, click on it, the drop down menu will appear. You don't have to select anything else apart from ppm excel. If in the process you forgot the name, please, you might be carrying any pen or paper right now while seeing this live stream. Okay, so just write down the names which I am telling to you so that you don't forget while selecting them. It is extremely important in analyzing the data sets. I am again saying it again and again. Please don't make any mistake. But still, if you do it and you are sending the report to us, we will tell you what was your mistake so that you don't have chances to do it with IESC. Okay. So you have to select PPM Excel and click on OK. And it's done. Your whole configuration is done until here. Now, one last step which you have to follow, and that is the Astrometrica. Go to okay. For me, it's licensed. Pardon? Yes, Aditya, from where do I need to? Okay, sure, I would definitely. Sure. I will definitely. As many times the students ask for, I will do that. Yes. So that you have changed the configuration. Let me revise that for you. The first, when the Astrometrica you opened from the C drive, the first configuration you changed was the ps1.cfg. That was the telescope configuration. The second configuration was the ppmxl. That was your star catalog. Then the last step which you have to follow is you have to register your Astrometrica. The Astrometrica you downloaded maybe on a trial version. So to register itself, go to the help as you can see on my screen, click on it, and you can see it's written register, right? Click on it. Yeah. Now, for me, it's already licensed. The license and the be provided you receive from IASC. Okay, you have to use that same license and key for the registration and make sure that you register your Astrometrica software, else it might collapse in a month or two. Okay, now once done, all your configurations are fine until here. You are left with nothing. But now the last steps comes over here. That is the climax of the whole movie. That is actually you are going to now search for the asteroid. Okay, how you are going to do that? Let's see. Go on to the files and click on load images. Now you remember that once when you were downloading the practice dataset, I make sure that you do it on your desktop for easy accessibility and that you extracted it over there. So I'm going to the same place where I did it. So that is my desktop. I went on to there, scroll down and searched for the place where the dataset is available. Can you see on my screen it's ps1 201 30306 and the set number name is 201. Now this is the name of the data set. It is extremely important. Now why is it extremely important? I will tell you later on. But before that, you just have to open this. Click on it, go on to it, and you will see these four images. These data sets are the four images of the night sky taken by PS1. I hope it has been clear to you by now very much. Okay. So simply click on open and the image will be loaded on your screen. Yeah. Let me segregate that for you so that it is very easily convenient for you to see them. Yeah. Now This is how it looks like, these four images. Now you might be thinking, sir, what is this? We were thinking that it would be a big asteroid and we would be seeing it with live beautiful asteroid with its shape, but it's not that. The asteroids are present at a very far distance from us. Okay, they might seems to be close, but they aren't. And that Aditya sir would have told you that these images are taken by PS1 telescope up to the magnitude of 24. That is up to, even the telescope takes the image up to 150 2 to 3 sorry 150 million light 150 million kilometers away. And this is how it looks like. The gray color which you are seeing right now at the background of each image is basically the sky. Okay, the night sky. And the white dots on each of the data sets are the objects which can be a star or an asteroid. So how you are going to do that? In these four images which are almost similar, that it's hard to say that they are even different from the other, we are going to spot that yes, this particular white spot or this particular white spot is our asteroid. Well, it's very simple. Let me recall you. Do you remember when Aditya sir showed you a image of dinosaur skeleton, and he asked you to spot the difference? You weren't able to, but soon after a process, it was very easy for you to spot the difference. Do you remember the name of that process? Okay, let me see once again who has the highest IQ in all of you and give the answer of it exactly. Can anyone name the process which we used? I'm waiting for your answers in the comment section. Yes? Yes, fine. Okay, let me tell you. The process name was blinking. So the same process is what we are going to do over here. That is blinking. Okay, but before that you have to remember one thing, that is you have to do the data reduction. Okay, as you can see over here below the astrometry, a green file, that is it, writing astrometric data reduction. Can you see? Yes. Now take your cursor over there, click on it and click on OK. Now it's taking its time. Let me see if it is loading. Basically, it is loading the data and it gives address okay, with the reference of which, with the help of which you are going to search for your asteroid and going to name it. So let the process happen. How many of you are excited for searching an asteroid and getting that fame all over the world? That yes, let's say your name is Aditya or anything else and you get that highlighted all over the world, that yes, a person named Aditya or any particular with your name had searched for an asteroid in the space and is now a mature scientist. He is now meeting scientists all over the world, NASA, ISRO. You are getting that exposure. Now imagine, and those steps are very simple which I'm showing you right now. You just have to follow them. Okay, now yes, you can see on my screen it's done. The table will appear. It will just tell you about the details of the objects which are present on the data sets. You have to do nothing but just simply close it. But this step is important before the process of blinking. Do remember to make sure that you have done the data reduction. Okay, now once done, you close the table. You have to do the last step, that is data blinking. How you are going to do that? You have to take your cursor to this dice like structure on your screen. As you can see, it's writing blinking current image. Do nothing but just click it and it will take, yeah. Okay, beforehand you have to also make sure that just a second. Select stars. Yeah. While you are doing so, make sure that you are tapping before blinking the process. You know you are taking your cursor to this point, the black color. It's written known object overlay. You have to just click on it and just wait. Now, why is it important? Basically, it tells you that what all objects have already been searched. Let's say you are getting the second data set. In the first data set, any student have already made a preliminary discovery. And now in the second data set, you have to do the provisional one, right? Because the particular asteroid has already been searched, but you have it is not yet confirmed. And now that the image was taken up by the pan star and it was sent to you for a provisional, that is the confirmed discovery, and you got that. Okay, so you make sure that you do this step so that you can see that in the data set which object was already been discovered by the students beforehand. As you can see over here on my screen, there was an asteroid over here which was already been discovered. Okay, once done, that's it. You don't have to search it again. You have to search for the new asteroid. Now how you are going to do that? You have to go to the dice like structure and do the blinking part. Click on it and it will start. Yeah, let me enlarge this for you, sorry, so that you can see it clearly. Hmm. This is how it looks like. Now can you spot what is happening over here? The asteroid which was already searched, it's moving. You can say the name of it, and you have to do the same process. The images you can see over here, the images are changing. One, two, three, four. The all the four images are being played one after the another like a GIF file. Let me give you a very basic example of it. You all might be loving cartoons. Like I personally love Tom and Jerry, Augie and the Cockroaches, or the Doraemon. So have you ever imagined or thought like how is it casted on the TV? Now what they do is they take the still images of the cartoons, okay, and they set it one after the another like a reel system, and they play it at a higher speed, and by this means you get a GIF file, or you get a animated movie that is the moving part of the images. Okay, and that is what it is done over here. We by the process of blinking we are playing all the four images one after the another, and it is creating a GIF file of it, and you can just going to search for the asteroid. There are so many white dots over here. How and the asteroid can be very small. So how are you going to search for them? So the process is simple. You simply zoom it. How you do that? You take your cursor to this option of zoom in. Okay, click on it, and the image will be enlarged for you. If you click once again, and it will be doubled enlarged for you. Okay. Now I think it will be very easy for you to spot the objects, okay, and visualize them. Now this is a process, this is the last process, and this is a process of patience and extreme focus, because your asteroid can be small and you have to spot a very small asteroid in the whole process. It is very simple. Now let's, if you are seeing it on your screen, let's search for an asteroid which is moving, that is the white dot which is moving. If anyone spots it before me, please do it on the comment section and a thumbs up to him. Okay, from my side. Can you spot any? I think this is still. No, we can't search any so far. Uh, Going back. Uh, Cancel. And yeah, yes. Now can you see spot over here? There is one dot which is moving in a straight line. How many of you are able to visualize it? Please tell me in the comment section. How many of you are able to see, spot that white dot? Comment session. I need all of you answer. If you are not able to spot, let me enlarge once again for you. It's over here. Somewhat. Now it will be very clear to you over here. This white dot is moving. One, two, three. It's visible in the three images. Yes. Were you now able to done? Do it. Search for it. Fine. So what you have to do next is you have searched for an object. Now you have to report it. But but before reporting, there are certain conditions which an object needs to fulfill before we can report it as an asteroid. Now, what are those? The first one is it has to move. So, is our asteroid moving right now? Yes, it is. So, it is fulfilling our first condition. The second condition is it has to move in a straight line or almost a straight line. So if you can spot, it is moving in a straight line. Okay, it was here, then here, then here. It's in a straight line. So yes, it's again fulfilling our second step, second condition. Then the third step, it should be visible in minimum 3 images. Now, since the blinking is very fast, so you might not be able to spot that. So let's decrease the speed of the blinking. You can do that. How? You simply have to take your cursor to this point where it is written 3 or whatever it's mentioned on your screen, blinking frequency. And you just click on the lower tab and it will decrease the speed of it. Now you can see it's moving very slowly. The image 1, then 2, then 3 and 4. So if you are able to notice, the asteroid is not present in the first image. It's somewhat behind the image that is given to us. But in the second image, it comes over here, then third over here, and in fourth over here. So it is visible in minimum 3 images, that is 2, 3, and 4. So yet it's fulfilling our third criteria of being an asteroid. Okay, so done. We can say that it is an asteroid. So let's see, there are certain more conditions which you need to fulfill. Beforehand, let's stop the blinking and name this asteroid. I stopped the blinking on the image 2, as you can see, because it wasn't visible on the first image. And you can spot over here, this was somewhat our asteroid. Let me play once again for you so that you get the assurance. This is what I said was our asteroid. Okay, let me play that once again. You get the assurance of an asteroid. Sure, sir, I will do that. Mm, okay, students, let me repeat my last step. I think I am audible to you right now and my voice is clear. Yes, you can write in the comment section. Am I clear to you? Fine. So what we did was we stopped the blinking part, okay, by tapping onto here. And we somewhat saw that this was our object which was moving. Okay, let me play it again for you. And it's moving. Yes, the object is fine. So I again stopped it on the second image and took my, this was the object which we have rectified. Okay, so it's simple. You just take your cursor over there on that same object and click on it. And a dialog box will open with the name object verification. Now, there are two more conditions which an object, sorry, three more conditions which an object needs to fulfill to be a asteroid. The first three was simple. Let us repeat together. The first one was it must move. Okay. So yes, our object was moving. The second one was it must move in a straight line or almost a straight line. That also you saw that yes, it was moving in a straight line. The third one was it should be visible in minimum 3 images. And yes, it was visible. It can also be visible in all the 4 images. It completely depends upon which data set you have got. Okay. In my data set, it was just visible in 3 images data set. So fine with it. It fulfilled the criteria. Now coming back, you stopped the blinking part, you took your cursor over there, and you just clicked on it. Okay. So once done, this dialog box has opened on your screen. Now there are three more conditions which you need to fulfill, and that are: first one, the magnitude. As you can see, it is written with the name R over here. Okay. The magnitude must be fairly constant in all the image dataset where you have spotted the asteroid. Let's say we spotted it in the 3 image dataset, so it must be constant in 3 datasets. Okay, we will check whether it is 20. It is all or also your magnitude, if fluctuating, can only be fluctuating up to plus minus one. That is, if in this dataset your magnitude is somewhat 20.2. So it can only fluctuate up to 19.2 or 21.2. That's it. If it is fluctuating more than that, then it's not an asteroid. Okay. It must be fairly constant. So we will check whether it is constant or not. And the second part, that is SNR. Well, the SNR stands for signal to noise ratio. Now that the telescope is taking the image, it's analyzing it, it's processing the image in a electrical form, and it's giving us the images. Okay, so that is why we get it in this form. That is, we have the SNR value of each object. You have to remember that your SNR value must be more than 5. Okay, I am again repeating, your SNR value must be more than 5, else it won't be categorized as an asteroid. So since it's 6.1, so yes, it's fulfilling the criteria. And the last step, that is the curve over here. This curve is known as Gaussian curve. So the white dots which you are seeing over here must be aligned with this curve. It must not be that white dots are over here and your curve is somewhat like this. Okay. Now that you can see, it's almost aligned like this. So yes, it's fulfilling all the criteria of it. So we can name our asteroid. We have searched an asteroid which is fulfilling all the criteria, and we have discovered it. Tell me, was it tough for you to search an asteroid? Was it tough for you to understand what is an asteroid, or how you downloaded the Astrometrica, or how you do the process, or now that you have searched an asteroid? No. So simple. This is how you are going to search an asteroid. Okay? When you are doing it on your own, it will only take 5 to 10 minutes. That's it. So I think that is much of the time you can give to the dataset for being a discoverer. Okay? Now coming to the naming session. That you have searched an object as an asteroid and you have to name it. How you are going to do that? The process of naming have to be typed over here in this session, if you can see on my screen. Okay? How you are going to name that? Should I write, let's say my name is Harsh, and I should I give it a name of Harsh? No, it's not happens as such at the beginning, at the preliminary stage. What you do is, there is a certain nomenclature which IASC follows for naming an asteroid, and that is, do remember, it is very important, very very important. I am again saying, the naming nomenclature should be somewhat like this. It must have 3 alphabets and 4 numbers. Okay, because if it is not like that, your report might be wrong. So let's say we are giving it a name like ASE1234. It has three letters, ASE, and 4 numbers. Just click on accept, and you can spot over here on my screen, it has been given a name with the pink color. Let's again confirm it. Was it right or wrong? Again, we are starting the blinking part by clicking on it, and you can see over here, yes, it's the right object which we have given the name to. Now, what's next? You have to check for the last two conditions in the other two images and give it a name. And that's simple. So again, you stop the image at the third image, because the second one you already have given it a name. Now the object is somewhat here. You again do the same process. You take your cursor over here, click on it, and the dialog box will appear. You check for the magnitude. It's fine. The before one, it was 20.2 and now it's 20.3. It's completely fine. So yes, it's fulfilling the criteria. The SNR value, it's more than 5, that is 6.4. So it's again fine. And the Gaussian curve, it's even aligned with it. So yes, our object can be an asteroid. Now, my question comes here to everyone. I need a answer from everyone in the comment section. Should the name be same or different? Let me give you 5 seconds to answer this. Let me again ask my question to all of you. Should the naming part be same or the name which I have given to the object in the second image, should that be the same or should it be different over here? Just write same and different or different. Let's see who all are correct in their observations. Okay, fine. Well, now let me tell you the answer. Those who have said that it should be same, you all won and a thumbs up from my side. Good. Since the object is same, it's just changing its designation. So you have to write the same name because the same object, you are naming the same object. Okay. So do you remember the name which I gave it? It was ASE1234. Three letters and four numbers. And just click on accept. And then again, the name is visible on the third image of the object. Let's play that once again. Let's increase the frequency of the uh, blinking so that you can see it clearly. So yes, the object is same. Now you have to name it over the fourth image, which is over here. So let's minimize the blinking frequency and stop the image at the fourth set. Stop. And this is our asteroid. So just click it. And let's check the magnitude again. It's 20.6. It's completely fine. The SNR is 5.6. That is more than fine. It's fine. And the Gaussian curve, it's also obeying the criteria. So yes, let's name it. And you all know that the naming should be same. So let's give it a name ASC1234 and done. That's it. Just play and check whether you are right. You have given the name to the right object. So yes, see, you can now fairly see it on your screen, right? It is all correct and your task is complete. You have searched for an object and you have named it. Now, what was the third step? Do you remember at the beginning I told you? Let me recall that for you. Submitting the report. Yes, you have to generate and submit the report. Now, how you are going to do that? You take your cursor to the file option, click on view MPC report file. As you can see over here, click on it and you can see this. Let's say we have given the name in the three image sets with AC1234. It's mentioned over here. So it's completely fine. All the things are good. So you have to do nothing but simply select it with your cursor and right click on copy. Now nothing, just close everything. You have to just submit the report. How you are going to do that? Yeah. Until here, I think the steps were clear to you that you named the object, you went to the file option. From there, you selected view MPC report, and there you got this dialog box on your screen where you selected the whole report and just right click and clicked on copy. The report was copied. What's next is that I hope you remember that when I was telling you the stage of downloading the dataset, I told you that you have to remember that the same page will be used for submitting the report. Now, as you can see, from here, you have to select from this drop down menu over here. You have to select the right image set which you analyzed right now. Okay. Once you will select that, do remember that you check it 3 to 4 times. It must not be wrong. You have to select the right image dataset which you have analyzed. Once you select that, you simply over here, you simply scroll down, and then you have to add your name as a citizen scientist. Okay, who that is the one who have analyzed this particular image sets. Now, if the first time, if you would be doing it on the IASC website, there won't be any name over there. It would be completely blank. You have to write the name of both of you. I hope you remember this, that two persons are participating in a team. Okay. Now there are two things you have to remember. One, the naming criteria, and the second thing, which is extremely important, is that you, since you both are working in a team, it must not be that you both should generate two different reports for one data set. For the same data set, only one report must be submitted. That is, either you should do or the other person should do that. Please don't submit two different reports for a single data set. Coming back, so how you have to write your name over there? You have to take your cursor over here to add citizen scientist, click on it, and over here in this dialog box you have to write your name. Let's say my name is Harsh Srivastava and my colleague or my teammate name is Aditya Jaiswal. So we are working in a team for searching for an asteroid, and that we have searched it, and now over here we have to register ourselves. So it won't be that I would write my complete name as Harsh Srivastava and the second name as Aditya Jaiswal. Okay, the correct process, it must be like H dot Srivastava and A dot Jaiswal. That is the first letter of your word, the first letter of your name, dot, and the title. Okay, do remember that that's how it is done over here. Okay, now once done, it is fine. You have added your name, you have selected the right data set, and now the last step, that is submitting the MPC report which you have generated. You simply scroll down over beneath the add citizen and you will get a dialog box like this, blank, written MPC report. You just click on it, right click, and you paste the report which you had copied from there. Okay, this was how it looked like. I hope you remember. And then nothing, you just click on submit report and your report is submitted and your task is done. Okay, now here is one last question from my side to you all. Okay. What if your data set has no moving objects? Now, there can be also chances that your data set can contain more than one moving object. Okay. That your data set could have two or three moving objects, which can be an asteroid. Okay. So, after that, you have searched one. Don't stop your observation over there. Do again check the whole data set, that whether am I missing any other object or not. Okay, there can also be a possibility that your data set is not containing any moving object. What would you do that? What would you do in that condition? Well, you remember that since you all are science student, so getting a zero result in science is also a result. So remember, in our case, we gave it any random name as ASC1234. Okay, what you do over here is, let me show you. Let's say this was the report which was created by me. Okay, and I had no moving object, and this was the report generated. So you simply have to copy mm, this. Yes, what you have to do is you simply have to select any object which you want, a white dot. Okay, and you have to give it a random name in any of the data set. Okay, you have to only do it, once again I'm repeating, when there is no moving object in your data set. Okay, now when you will generate the report by going on to the file settings and selecting the view MPC report, this is how your report will look like. You have to do nothing but select the one which you have given it a random name, backspace, and you have to write over there no moving, like I'm writing over here, no moving object objects detected, and that's it. Okay, and you have to submit that report to the same place where I told you right now. You have to copy it over here and you have to submit the report. Okay, now there is few things which you have to remember, because the campaign is about to start on the 6th of Jan, and on the first day itself, that is on the 6th of January, you will be getting your first data set by IASC. Now, what you have to remember is that the first data set which you are getting from IASC is the practice data set. And why are they sending it to you is that they want that, they believe that the students who are participating over here are extremely intelligent. Okay, and though they know very well what is an asteroid and everything, which we have told you in this video. Okay, so what they expect is that you do the whole process very sincerely and in a systematic way properly. So they expect that the first practice data set which they have sent to you must be sent correctly to them, because if you don't do that, or if let's say if you have submitted the false or the wrong report for the first practice dataset which you have received from IASC, then you would not get any other data set. Okay, so do remember that the first practice dataset which you are getting from IASC, you have to analyze it correctly and submit it correctly. Whatever problem you have, how many times you have, we are here to help you. Our whole team is working behind this whole process, and we are here all the time, 24 into 7, working for you. Okay? So please remember, follow our steps, view our video back to back once again, like it, subscribe it, keep it with yourself, and do watch it as many times with you wish when you are doing the steps, when you are following the steps to make each steps clearly, and you have to submit the right report. Now, here we are helping you in a process. How? You might have received a KASC kit, right? If you check your email. Now, that would also contain practice data sets from our side, which is not sent by IAC. I'm again clearing it. It is not sent by IAC, but us, that is Space India. Okay. So, what you have to do is you can simply, before the campaign actually starts, you can simply practice those data sets and send the report to us. Okay, we will send you the ID or the contact number on which you can submit the report. You please remember, you do not analyze and submit those reports sent by us to IASC. Okay, you just have to send to us. To tell you at the initial stage, the Gmail which you have to follow for sending the report to us, for which we have sent the practice set, is KASC, that is Khagolshala Asteroid Search Campaign @ space-india.com. It will be written on my screen right now, and you can copy it over there. Okay, but before that, please practice the data set which we have sent to you and send us, so that we can tell you if there is any error in that, so that you can correct it beforehand, and you can set your hands onto that, so that when the original data sets comes from IASC, you have no problem in solving it, and you are soon getting that discovery. You are soon getting that award of discovery. Okay, so let's do the revision of everything which we have learned by so far. The first step, what was? Downloading the dataset from IASC website. So we just opened the IASC website, that was iasccosmosearch.org. We logged in into that from the email and the password, the email which was given to us during registration, and the password which was sent to us by IASC. We scroll down, we search for the database. Okay, and then we downloaded it. The second image was, the second step was analyzing it over the software Astrometrica. You got that Astrometrica software set up in the kit of KASC, which we have sent it to you. You just opened it, installed it. The first time you opened, the MPC report got updated. Thereafter, when the Astrometrica opened, you closed it on your desktop and again you opened it from the C drive. I told you the reason being for that. Again, when the Astrometrica finally opened onto your screen, you did the configuration part. That is the first one. I hope you remember the telescope configuration. That was ps1.cfg. How you changed it? You can again go back to the video and see it. The second one was the star catalog with the name PPMXL. I hope you remember because I have told it to you for the sixth or seventh time. Okay. If you want it, I will again tell it to you. There's not an issue. We just want that as many students should come forward with as many discoveries and should get the name of India to a maximum limit that it is मतलब सब पूरी दुनिया में पता चले कि इंडिया क्या कर सकता है आप लोग क्या कर सकते हैं दैट यू आर ऑन योर होम इन दिस कोविड सिचुएशन सिटिंग बट स्टिल working with NASA or ISRO or with us and you are searching an asteroid. Okay. So getting back, so you change the configuration, you loaded your image, you did the manual detection, you checked for the moving object, you did the data reduction part. First, you remember, do the data reduction part before the blinking, okay? Then you check for the known objects, if there was any, so that you can't name it again. Then you do the blinking part, so that you search by that process, you search for the moving object, you copied the report, and the third step that you edited the report and submitted it online to the same website. Now, this is the mail ID, what I was telling it to you. The practice dataset which you have got in the KASC kit, the KASC at the rate space dash india.com. This is the same ID on which you have to send the report to us. And these are our contact numbers. We are available to you anytime. You can feel free to contact us if you have any query in the steps. Okay. Now, one last steps come that uh, you know that how you are going to submit the report to IESC. But before that, how you are going to submit the report to us. That is the practice dataset which we have provided to you now. So you are simple. You have to do the whole process completely the same. You just have to open the Word document. And let's say you can over here copy the whole report. Okay. Which you have generated from there. Close it and save it. Yes. Close it and save the name of that file with the name of your data set. Let's say I had it as PS1 this. So I will save it with the same name and then I will submit it to you. Now, how's that? I'll open my ID. I'll get on compose, copy KSC at the, sorry, KASC. This is our ID, that is KSC at the rate spaceindia.com. Write the subject as practice data set submission. Okay. From here, select the data set which you have copied from there and made the file. Do remember once again, I am saying that you do make the name of that same file with the same image set which you have analyzed because we don't have any drop down menu for you. Okay. This was the image selected. Now you can write over here your college name, sorry, your school name and your teammate's name if you want. And you can directly send it to us so that we can analyze it beforehand and tell you if there is any error from your side. Okay. This is for your own benefits. Okay. So that was all from our side. Just a second. Yeah. So this is, so with this workshop is completed and I hope that you have learned everything. Okay. Everything was clear to you about Astrometrica and how to go through it. But remember, the work is not yet done. It has only started. Okay. So you have to stay motivated and patient and do all the queries. Do remember to like our page and follow us. Okay, for any query, we are there. I believe in you all, and I believe that I would soon get to meet you all with the scientists that you have discovered an asteroid. Okay, so thank you. Have a nice day. Bye. Any queries until here? Please write in the comment section so I can see. Okay, fine. Thank you. Thank you. Okay, fine. I'll do that again for you. Well, you can see over here. I think my screen is not present. Let me do that for that. Yeah. No, yes, it's fine. I think I'm visible to you all. Let me close it. Getting back. Yeah. I hope you remember that we are not going to open the Astrometrica from the desktop, right? Because it's again going to take our time. So I'll again do it from the C drive, as you all remember. Open the Astrometrica. Let it do its process. It's almost done. Okay, how many of you believe that there are aliens in the space? MPC, click on yes. Yes. So yes, Aditya asked me a question that if there are two objects, how we are to going to do that? So let's again load our image. Selected all the fours. The image was loaded. We did the data reduction. The first step, we check the configuration. It's fine. PX1, PPMXL. Click on OK. Let the data reduction happen. Yes. So I asked you a question that how many aliens? Well, do you know what Stephen about Stephen Hawking? What he told us that yeah, not believing in aliens, it's like you are taking a spoon of water from the sea and saying that since there is no shark in the spoon, so there couldn't be any in the sea as well. Our galaxy is very small, and that our Earth is even smaller. It's not even visible. Our universe is so big, and it is said that there is almost hundred or thousands, or there could be at least 10 millions of the species living on the in our universe, which can be like us, which can be different, which can be even like koi mil gaya ka jadoo, friendly with us. And I hope and I believe that someday we will discover them just by as we are discovering the asteroids. Okay. So we did the data reduction. We tap on to the blinking part. First, we check for the known objects. Let's check it over here. Let's go on. Yeah, known objects, just in case to see if we are not naming the same object again and again. Well, let me tell you one more thing that there can be chances when you have first installed the Astrometrica and you are getting any error like MPC or not updated, or any generating any data, sorry, any error as such. So what you have to do in that case? Okay. So let's say because of any issue, your MPC data was not able to be updated. So you have to do nothing but simply your Astrometrica will open. You have to go on help. Sorry, you have to go on internet, and from here you have to select update MPC or download MPC orb, and your MPC will again be updated. Okay, there is not an issue. The uh, errors can be solved with this. Once again, I'm saying if you are getting an error that your MPC file did not update, you can go on the internet over here and click on download MPC or update MPC or the first error which you might face. The second error which you can face is while data reduction, that your data reduction couldn't happen properly. So what you have to do, you have to click on this, go on internet, and you are be seeing over here the Visor server. You simply have to change this fiber server to any other place all over the earth. Okay, and just click on OK. Once done, click on save. And once again done, then you again have to do the data reduction part. If you face any error before data reduction, this is the process you have to follow. Do follow our video back to back if you face such issues, or you can directly call us. This is the error which has been reported to us, and we will be here to tell you what is the step you have to follow. Okay, so coming back, you have to do the blinking. Now the image has started. Let's say in this image there are two objects. Okay, let's say this object is moving and this particular object is moving, and these are both the asteroid. The same process you have to follow. First you have to check all the 6 criteria if it is an asteroid or not. But I'm just telling you for the sake of how you are going to name an asteroid if there is two discoveries. Okay, in an image set. So you just select that, take your cursor over there, give it any random name, ASC 1, 2, 3, 4, in all the 4 sets when it is moving. Once done, the image will come over here, as you can see. And let's say the other object is this. So again, you tap on it. Now, since the object is different this time, you have to name it different. Let's say I give it a name over here, ASC 5678. The names are different right now. So you again do the accept, and again it will be named. These two asteroids you have searched. Only do it when it's fulfilling the criteria of being an asteroid. Not I am specific. Once done, click on view only these two different objects which you have reported. Simply copy the report and submit it to us as I told you. Is there any other questions which you need to ask me? I am here. Please message us or write in the comment section. Let me share until then with you our ID so that you can jot down. It was over here, yeah. This is our email ID where you have to send the practice dataset which we have sent it to you. And here is the contact number. Okay. So with this, our campaign ends here. All the best to all of you once again. Please subscribe our video.
Okay, so that's all from the side of my fellow colleague Hirsch. I hope he explained all the details to you well and good enough. I hope you now know how you have to find asteroids, how you have to file a report, and how you have to send it and send the report. So basically, he told you that firstly you have to practice on the data sets, the practice data sets. for which you will be sending the report to us, okay, at the at the email id he told you, kasc space hyphen india.com. Okay, he told you, Harsh sir told you that, okay, what happens when you find more than one moving asteroid? You have to name it, like the first asteroid, you have to name it. Let's just say it is present in 3 images, so you will name it in 3 images. Then, if the second asteroid you found, it is present in 4 images, you will have to name it in the 4 images, and make sure that you name both the asteroids separately and with a different name. Also, take note of the pattern. The pattern is, or for naming an asteroid, is 3 letters and 4 numbers. If you still have any queries, if you still have any queries or anything that you might want to ask us, or any step that you might have missed, and even by watching, like, this video will be available to you, like, for any time you want, even if you want to watch it like sometime later, like 5 hours, 10 hours, 12 hours, or even a day later or 2 days later or so, this video will still be available to you. So not to worry, this video is always here, so any step you missed, you can rewatch it using the video. But still, if you are getting some errors with your Astrometrica software, or some things are left unclear to you, you can always mail us the issue. The email id has always been already been shared to you, so do not worry, we are here for you. We will help you with everything and whatever you need. And so let's just go ahead, and when the campaign starts on January 6th, find new asteroids, make India proud, make yourselves proud, make your parents proud, and get yourself recognized in the international society. So this is me, Aditya Jaiswal, signing out. I wish all of you luck. I wish all of you good luck and happy hunting. And here we are ending with the Khagolshala Astronomy Search Campaign training. All right. So good luck and good evening to all of you guys.